Hello student. Today we will see the numerical based on the topic bending stresses. Now in the first numerical there is some given data. In the numerical it is said that there is one cantilever beam, and on this cantilever beam of span 4 meter a point load is acting at the end of 2 kilonewton. Find out the maximum bending stresses. Okay. So the dimension for our beam, it is given, this is basically a rectangular beam, and for this rectangular beam width is given of 50 mm, depth is given of 75 mm. We need to find out the maximum stresses in this case. Okay, so first of all we will write what is given in this numerical. So given the load is given or force is given, so W is equals to 2 kilonewton and which is equals to 2000 newton. Okay, the length L, it is also given, the length L is 4 meter and which is equals to 4 into 10 raised to the power 3 mm. Other dimension of B, that is B, is equals to 50 mm and the depth of beam D is equals to 75 mm. It is given in the numerical, and what we need to find out? We need to find out the maximum bending stresses. Okay, so as in this case our beam is symmetrical, so first of all we need to use the formula, that is bending stress equation. Now in this case we know that the bending equation or the formula which we need to use, it is sigma by y is most important for exam result. So in this formula there are 6 terminology, or you can say here 3 ratios are given. You need to use any 2 of it to find out the maximum stresses, that is you need to find out the value of sigma. Okay, now first ratio it is sigma by y, now second is m by I, e by r. Now check what is given in the numerical, and according to that you need to use the ratios. Okay, so sigma is the stress, that definitely we need to find out. Y is the distance from the neutral axis, m is the moment, I is the moment of inertia, E, that is the Young modulus, it is not given in the numerical, and R is the radius of curvature, it is also not given in the numerical. So we simply need to use the formula as sigma by y is equals to m by I. Okay, so this formula we need to use. Okay, that is sigma by y is equals to m by I. Now, first of all, find the 3 remaining terminology in the formula. So, first of all, the value of moment. Now, moment m. We know that for this case, moment m will be force multiplied by perpendicular distance. So, force it is of 2 kilonewton. Distance of 4 meter, we already simplified, so this became load into distance, so which is equals to load, it is of 2000 newton, so it is 2000 multiplied by distance, it is 4 into 10 raised to the power 3. So the moment m, it will be 4 multiplied by 2, it will be 8 into 10 raised to the power 6. And the distance of moment, the unit of moment will be Newton mm. Okay, so this is how we have find out the first terminology here, which is moment. Next one is the y. Y, it is the distance from neutral axis, और जहाँ पे आपको stresses निकालने हैं. In this numerical, we need to find out the sigma max. So sigma max will be at the extreme fiber from the neutral axis. So इसका मतलब हमें यहाँ पे जो वैल्यू लगने वाली है वो y max लगेगी. This will be a y max this will be a y max, and which is equals to d by 2. यहाँ पर रेक्टेंगुलर सेक्शन है, रेक्टेंगुलर सेक्शन के लिए हमें पता है कि न्यूट्रल एक्सिस और हमारा एक्सट्रीम फाइबर जो है वहां तक का डिस्टेंस d by 2 रहता है. So which is equals to d by 2 for rectangular section. So in this case y max is equals to d by 2, and depth it is 75. So it is 75 divided by 2, which is equals to 37.5 mm. So यहाँ पे हमने y max या y की भी वैल्यू हमने निकाल ली है. Now I is the moment of inertia for rectangle. So we know that for rectangle moment of inertia it is bd cubed by 12. Okay, and what is the value of b in the numerical? It is 50. What is the value of depth? It is 75 cube and divided by 12. So if you simplify it, you will get the answer 175,7812.5 mm raised to the power 4, as it is the moment of inertia. Okay, now we have find out the value of moment y max and moment of inertia. Now just put this value. So maximum stresses or maximum bending stress sigma is equals to sigma t or sigma c, means compressive or tensile stresses. Now in this case our beam is a cantilever beam, and for cantilever beam when load is acting vertically downward, then in that case if I draw a bending stress profile, then it will be like this. Now when the beam is cantilever, load is acting vertically downward, a tensile stress will act on the top part and compressive on the bottom. So यहाँ पे हमारा सिमेट्रिकल बीम होने की वजह से जो भी स्ट्रेसेस की वैल्यू रहने वाली है, हमारा y max अपर साइड में भी सेम है, लोअर साइड में भी सेम है. तो हम ऐसे कह सकते हैं कि बेंडिंग स्ट्रेस सिग्मा इज इक्वल्स टू सिग्मा टी और सिग्मा सी, दोनों की वैल्यू कैसे रहने वाली है, सेम रहने वाली है. एंड फॉर दिस यू नीड टू यूज द सिंपल फॉर्मूला, that is sigma by y is equals to m by I. Now when you find the value of sigma or sigma max, then in this case it will be m by I into y. So it is m by I into y. Okay, now just put the value. When you put the given values, moment it is 8 into 10 raised to the power 6. Okay, the value of moment of inertia, it is 175,7812.5 into the value of d, it is 37.5. So in this case you will get sigma max, which is equals to sigma t and which is equals to sigma c as 170.66. स्ट्रेस है इसलिए यूनिट विल बी न्यूटन पर mm square. So the maximum stresses at the extreme fiber will be 170.66 Newton per mm square, and similarly for sigma t it is 170.66 Newton per mm square. Okay, so this is how we have solved the numerical. Now second numerical, there is a one little change in our numerical 2. Now in first numerical, a simple cantilever beam is given with a load acting at the extreme end or free end. Now, in this case, a UDL is acting over a cantilever beam. The loading pattern is change in second numerical. So, in this case, one cantilever beam is given with a span of 2 meter and load intensity of 20 kilonewton per meter. Now, in this case, the dimensions are 150 width and 300 is the depth. So we need to find sigma max. Again, this is our similar section. So we will just write down what is given in the numerical. So given terminology in the numerical, first of all, loading intensity it is given. It is 20 kilonewton per meter. Okay. So next is the length. Length L, it is 2 meter. So which is equals to 2 into 10 raised to the power 3 mm. Okay. Now next, what is given? The value of width. It is 150 mm. And the depth, it is 300 mm. It is given in the numerical. And again, what you need to find? Now, in this case also you need to find the value of maximum stresses. Okay. So again, the formula you need to use is same, that is sigma by y is equals to m by I. Okay. So now in this case, first of all, we need to find the value of moment. So moment for cantilever beam carrying UDL M, it is WL square by 2. This is the standard formula. I think every one of you know. That is moment, it is WL square by 2. So if you put the values, that is W, it is 20, length, it is 2 meter. As I am putting here, it is in 20 kilonewton per meter. So I am just putting the length also in 2 meter. So it is 20 into WL square by 2. So after simplifying it, you will get the value as 40 kilonewton meter, or if you want it in mm, then it is 40 into 10 raised to the power 6 Newton mm. Okay, so this is the value of moment which we have found out. Again, for this case, y max is equals to d by 2, क्योंकि अब फिर से रेक्टेंगुलर सेक्शन है. प्रीवियस न्यूमेरिकल में भी हमने देखा था कि रेक्टेंगुलर सेक्शन है, हमें एक्सट्रीम एंड पे एक्सट्रीम फाइबर के लिए जो है स्ट्रेसेस की वैल्यू निकालने को कहा था. तो इसलिए यहाँ पे y max is equals to d by 2. हमारी डेप्थ जो है इस न्यूमेरिकल में जो दी है, it is 300. So it is 300 divided by 2, so which is 150 mm. It is, we have find out the value of y max. Again, the value of I, moment of inertia, I is equals to BD cube by 12. So जो यहाँ पे B की वैल्यू है, width, it is 150 into यहाँ पे जो डेप्थ दी है वो है 300 cube divided by 12. So after simplifying it, you will get the value as it is 337.5 . The value is 337.5 into 10 raised to power 6 mm raised to the power 4. So here we have find out the value of moment y max and moment of inertia I. Now just simply put the value in the formula. So sigma max is equals to, again, sigma by y is equals to m by I. So sigma max is equals to m upon I into y. Or here you can write it as y max also. So moment, the value of moment, it is 40 into 10 raised to the power 6 upon I. Moment of inertia, it is 337.5 into 10 raised to the power 6 multiplied by the value of y max, it is 150. So you will get the value of sigma max. The value of sigma max here, it is 17.77 Newton per mm square. Just like previous numerical, this is a cantilever beam and it is a symmetrical section. So for this case, when you draw the bending stress distribution diagram, so this will be a sigma c and the value will be same as sigma max, it is 17.77 and sigma t is also 17.77 Newton per mm square. Okay, so this is how we have solved the numerical. In the first numerical, simple cantilever beam carrying a point load at the free end, and in the second case, a cantilever beam carrying